Welcome to Survey Matters with Duncan-Parnell. My name is Mark White, and I'm the Training and Support Manager for DP. Today, I want to talk to you guys about GNSS site calibrations. But first, be sure to hit that like button and subscribe. All right, so site calibrations in Trimble Access. We get a lot of support questions about this, and this comes up in training a lot. How do I do a site calibration in Trimble Access? What is a site calibration in Trimble Access? And when do I need to do a site calibration in Trimble Access? So I want to cover those things today and then actually show you how to set up a job properly and then how to do a site calibration and read the results out in the field. So first of all, what does a site calibration do? All right. A site calibration calculates the parameters for transforming global coordinates, what your GNSS receiver measures, into local grid coordinates or northings, eastings, and elevations of your control points on the ground. So think of it this way, it's just creating a relationship between those global coordinates that your GPS receiver measures and the local coordinates or the grid coordinates of your points on the ground, creating a relationship there so they'll work together. So when should you perform a site calibration? I always tell people, anytime you're doing stakeout work, you should calibrate the site. Now, it's not like you have to calibrate the site every day or every week. You just calibrate it once at the beginning and then check in each day to make sure everything's working properly. But anytime somebody else has set the control, drawings have been made off of that control, and now you're going to lay out off of those drawings, you want to go calibrate to that site so that your GPS matches up with that ground control. And that way, everything that you lay out is going to match up properly as well. Okay. So the other time would be anytime you're working with local coordinates, and this could be assumed coordinates. Maybe you got an old job that's in 10,000, 5,000, 100, and you want to use your GPS with it. Maybe you're working on a site that's using plant coordinates, right? Where they just took north on a column line and put some assumed coordinates in there. Or you've got a ground coordinate system that somebody else set up and you want to make your GPS work with it as well. So anytime you're working with a local coordinate system, that site calibration will allow you to do that. So another question that comes up, how many control points should I measure in my site calibration? Trimble recommends a minimum of 4. And those should be evenly distributed around the job area and actually extend outside the site perimeter. Okay, so you get a good geometry of a minimum of 4 points around the site. Now, Access will actually use up to 200 control points. Most of the time, you don't need that many. Even on a large site with a lot of control, you can just pick points that are evenly distributed and surround your site and calibrate to those and then check into some of the ones that you don't use in the site calibration. So let's look at a couple of examples here. So this is a survey site, and of course this is like best case scenario, right? Survey site, and I've got 4 points kind of creating a box around it. So I could calibrate to those 4 points, and that would give me a good geometry. They're evenly distributed. They surround the site. And the reason you want them to surround your site and be outside the extent of your site is a site calibration is going to translate your GPS, rotate your GPS, and scale your GPS, and then do a vertical adjustment if you choose to do vertical to take your GPS coordinates and best fit what's on the ground. Now, the ground doesn't change, okay? The ground coordinates, your control, I should say, your control coordinates are the gospel. Those are going to stay the same. The GPS is going to get translated, rotated, scaled, and vertically best fit so that all your GPS shots match up with the control on the ground. So in a case like this, I've got 6 points here. I've got 2 that are kind of inside. I can calibrate to the 4 outside, and I like to leave 1 or 2 points independent of the calibration so that I can check into them. So if I calibrate to the 4 points that are around the outside here, and then I check into those 2 points that are on the inside, that gives me 2 points that weren't part of the calibration. If they check good, they're part of my control, I know my calibration went well, okay? So leave 1 or 2 points out if you can to allow for an independent check on your calibration. So that's a survey site that has control surrounding it. What about a linear survey like a roadway? So here I've got a winding roadway there that's got control going all the way down it. So you would probably at least want to calibrate to the two end ones and then pick points along the roadway that are evenly distributed, that's going to give you the best geometry. So maybe at the high and low points of the curves there, so that if I draw a box from control, around my control point, it surrounds the whole site. Do I need to do all those points? No. I could probably pick 6 or 8 points. This is about a 5-mile stretch of road. I could probably pick 6 or 8 points and be fine with it, and then use some of the other points as check shots. But again, you want to make sure they're evenly distributed. Obviously, you want to make sure you got a good view of the sky too. I didn't say that, but you do want to make sure you got a good view of the sky, and that could come into play in a roadway, right? But make sure they're evenly distributed and leave a few points that you can check into later. Okay, so that's what a calibration is, when we do it, and a few examples there on kind of how to set it up and what to look for in your control. So now let's take a look at the settings you need on your data collector. In Trimble Access, I'll go to the menu button at the top left and then go to settings. And what you want to do is take a look at any of the survey styles you might use for a site calibration. So this could be just your RTK survey style for regular base rover with radio, could be your IBSS for internet-based rover. You might have a VRS survey style, and on and on and on. So any GNSS survey style that you would do a site calibration on, you'll want to check your site calibration settings and make sure they're set up right. Now the defaults work pretty good, so I'll just take a look at RTK, and then down here towards the bottom, I've got a site calibration option. All right, there's a few things in here to be aware of, okay? You've got fixed horizontal scale to 1 and fixed horizontal rotation to 0. Now, some people will tell you should set that every time. I disagree, okay? The time you should set those is when you're working in a known coordinate system, like let's say I'm working in state plane and I am calibrating the state plane coordinates, and I know that my control is very good. Like maybe I'm using some NGS monuments that I know are very good monuments. I know there's not going to be much rotation. There's not going to be much scaling. And so I could set that horizontal scale to 1. I could set my rotation to 1, and I could do it that way. But most of the time we're doing site calibrations, we're trying to fit local control. So there might be some rotation in there. They might be ground coordinates that somebody set from monuments that don't match our VRS network, or they don't match up with our RTK for some reason. Not that the points are bad. The geometry on the points are good. They might have just come from a different source, or they've been scaled, or, the plant coordinates, whatever. But most of the time, when we do a site calibration, we're trying to take our GPS and best fit it to what's on the ground. So you don't want to check those boxes. All right. Now, vertical adjustment in newer versions of Trimble Access, it is always set to a constant adjustment only. And what that means is it's going to move your vertical up and down to best fit any error that's found between your GPS shots and your control point elevations, okay? So it's going to give you an overall best fit there. There's also an option for an inclined plane, and back in older versions of Trimble Access, that's all you had was an inclined plane. And if you're using an inclined plane, this would be something that you do like if you don't have a good geoid model, possibly, or if you're doing a site calibration that you're going to share with machine control that requires an inclined plane, you might want to set it here. But when you're using an inclined plane, remember, just like the name says, it's inclined. That means it's going to tilt east-west, north-south to best fit your control. So you want to make sure that you've got at least 4 good points that surround your site, or if you're running a linear traverse, you may need to throw control outside your site a little bit, out away from the road, so that you've got a good polygon that surrounds your road. Because if you use an inclined plane and you calibrate to points that are all in a line, it could cause your inclined plane to tilt and give you bad elevations the further out you get, okay? So in most cases, you're going to want to leave it on constant adjustment only and not use an inclined plane, all right? Then in most cases, again, you're going to want to use an observed control point, but you could set it to topo point if you wanted to take a shorter shot. I look at it like this is control work, right? So I want to use observed control point. And then the rest of it, I just leave the same. okay? I've never seen a real need to change any of this with the residuals, max min scale, maximum slope. Now you could change that slope if you were doing inclined plane to a value that you want it to alert you at. That's a nice feature there. But again, I would normally use constant adjustment only. That way it's just going to move my elevations up and down. I don't have to worry about tilt. Okay. And then down here at the bottom, the calibration point name, like if I calibrate to point number 1 in the field, it's just going to add a suffix of 1 GNSS to my control points, and that's fine with me, so I always leave that the same. Okay, so I'm not changing anything inside these settings. I just wanted to share with you guys what some of those settings were, but we're going to roll with the defaults for this because they work really good. All right, so now that that's set up, let's talk about how to set our job up properly. Okay, so I'll tap accept here, store that, escape. Now I'm going to create a new project and just call it SiteCal and enter and create that. And then the next thing is going to be setting up the job and the coordinate system properly. Okay, so I'm going to call my job name SiteCal. Whoops, not SoCal. SiteCal. Man, spelling is not my thing this morning. All right, SiteCal, finally got it. So I'll come down to the coordinate system. You know, choose your template for what you need. International feet metric. I work in a U.S. survey foot state, at least till the coordinate system gets updated. So we're going to stay with survey feet. And then we'll go to coordinate system. And down here towards the bottom, you've got an option for no projection, no datum. That's what you want to use for probably 99.9% of your SiteCals. Again, if you know you're working in state plane and you're calibrating to state plane monuments like NGS monuments, and for some reason you need to do a SiteCal to them, then I would select from library and do it in state plane. Otherwise, again, I'm taking GPS coordinates and best fitting them to what is on the ground. So I don't want to try to cram that into a state plane system when they're not state plane, or they probably aren't state plane. They've been localized somehow, right? So I want to choose no projection, no datum. I want to tell it whether I'm using ground or grid coordinates. Now, again, most of the time, especially if we're on construction sites, we're using ground coordinates, right? And then the other thing is the project height. I need to put a project height in here. Now, if I'm using, what I need to do in this case is look at the elevations on my control points and knock them down by roughly 100 feet, because that's what ellipsoid height is here on the East Coast of the United States anyway. Your mileage may vary. It's going to be different depending on where you are in the world. But just know that the difference between elevation and height in your part of the world, and take the average elevation of your control points. And that might be fake elevation, right? If I'm using assumed coordinates, I can be using 10,000 northing, 5,000 easting, and 100 for elevation, even though it's 400 outside. But what I want to do is use the average elevation of my control points, roughly take off the difference in the geoid height there. So in my area, depending on what my control is, it's going to be about 100 foot lower. So let's say we put 300 in for this. And then I do want to use a geoid model. In most cases you are, especially if you're using that constant adjustment, right? If you're doing something with machine control and they require an inclined plane, you could leave that box unchecked and just use the inclined plane. But in most cases, we're going to set it to ground. We're going to put a project height that's, the difference between the geoid or the geoid height, the difference between the ground and the ellipsoid in your area. And based on your control, check the box for use geoid model, choose your geoid model. In my case, the latest one is G18US, and I will store that. All right. Then I could go ahead and I could, add in a control file as well. So I could take a CSV of my control points, dump it in there, or link it to the job. But that's how you want to set your job up 99.9% of the time. No projection, no datum, ground coordinates, put a height in, add a geoid model. I'll accept that. And now we're ready to head to the field and do a site calibration. All right, we're out here in the field ready to start our site calibration. It's a little windy, a little cold out today. You may notice we got a little snow on the ground and I'm wearing a different color shirt. I actually did the office part a couple of days ago. Then we got a bunch of snow and I hadn't been able to make it out in the field until today. So a little bit chilly for a southern boy out here today, but we're gonna make it for you guys. Today I'm going to be using a base rover to do my site calibration, but this will work whether you're using a real-time network and just a rover or you're using a base rover setup. So if you're using a real-time network, you can skip ahead in the video to the rover segment. We'll leave some notes below so you can do that. But first thing I'm going to show you guys how to do is get the base started. Remember, we're doing a no projection, no datum job. So there is a little bit of a different way you have to start the base than normal when you're doing no projection, no datum. And we're not going to set the base up on one of our control points. I drove a nail in the ground here, and I'm basically going to do a separate control point, and we'll do what's called a here position, and that way we can use all our control that we want to use in the site cal and not have the base set up on one of those points. It's kind of like doing a resection, okay? So when you're doing a site calibration, find a good spot, you know, inside your control or right around the edge of your control. It doesn't need to be too far away, but somewhere around your control, set a point, do a here position like we're going to do, and that way you can calibrate to all your control, and the site calibration is actually going to generate good coordinates for your base point, and you'll have another control point at the end. Okay, so on the screen you'll see I've got 5 points here. Looks like we've got a Frontier flight coming in. We are near the airport, so you might hear some jet noise as well. But I've got 5 control points here. And what I'm going to do is I'm going to calibrate to 1, 2, 3, and 4. And then I'm going to check into point number 5 at the end, leave that independent of the site cal so I know that my site calibration worked really well. Okay, so like I said, we'll start the base first. I'll go to the menu at the top left, go to measure, and I am going to use my RTK survey style that's already set up, and I'm going to tell it I want to start the base receiver. Remember, this is a no projection, no datum job that we did. So instead of having a control point name in here, what I'll do is tap the black arrow and go to key in. And I want to make sure, so right now you see it's on northing, easting, and elevation. We need to change that since there's no projection in here yet. We can't use northings and eastings. The software doesn't know how to project the latitudes and longitudes. So what we need to do is go to the options button, do the drop down, and we'll choose global coordinates because we're going to pull a coordinate from the satellites, okay? So a global coordinate, accept that, then hit the here button at the bottom. If you get a message that it can't project it, it means you forgot and you left it on northing and easting. But if you change it over to lat, long, and height with global coordinates, you'll be able to do that here position. You'll see the latitude and longitude there. I'll give it a point name like 100, get it outside my, my control there, and give it a code of base. And now we'll just enter that, store it. Now we're ready to start the base. Just check, make sure your rod height is correct. I am 6.562 feet or 2 meters to the bottom of the quick release. So we're good there. I'll tap start. And now the base has been started using a here position. And again, our site calibration is going to generate good coordinates for the base once we're done with it. All right, let's go shoot the first control point. Okay, so I made it over here to my first control point, and I am actually on point number 1. Now, you don't have to go in numerical order. You can do these in any order you want as long as you take the shots on the right control point. So let me go ahead and plumb this guy up, get it good and plumb. And now what I'll do is go to the menu at the top, go to measure, choose RTK again, and this time I'm going to measure points. So it'll take just a second to switch over to the rover. It is turned on, just wanted to make sure. But then we'll get the software to switch over to the rover, and I'll show you how to measure a calibration point. All right, so we're connecting up to the receiver. Now I'm taking observed control points for these. Remember, we talked about that in the settings for site calibration. So we're not going to be using the IMU for that. It'll automatically turn off when we go to control point. So I'll accept that. So you'll see the IMU is not aligned up at the top, but once I go to measure a control point or a calibration point in this case, it's going to turn that off anyway, so not a big deal. All right, so things are hooked up. Right now, you'll see my measure points is set to an observed control point. So I'll go to the method and change it to a calibration point. Again, it says RTK, IMU not aligned, that's fine. I'm gonna put in the grid point, that's the point number of this point, which just happens to be number 1. Enter that. Software is gonna automatically make it 1_ GNSS. Check my antenna height and my measure to, that's all correct. We'll enter this and go ahead and measure. All right, and you'll see it went ahead and turned off the IMU because it's set to do a control point anyway, and we're down to 200ths by 300ths with the green check there at the top. All right, so 3-minute measurement. I'll see you guys in 3 minutes. All right, we're inside 10 seconds. We're counting down here to store the point. 3, 2, 1. All right, store button popped up. I'll go ahead and store it. And once I store that point, you'll see the software immediately takes me to the site calibration screen. Now, I've only shot 1 point, so I don't get any residuals yet. But what I want to do is hit the apply button down at the bottom, and that will apply this first point into the site calibration. And then I'll go to my next point and measure it. So we'll apply here, takes me right back to the measurement screen. I'm gonna go ahead and go up here to the top, turn off the IMU so that's not popping up all the time. And then we'll go ahead and head over to the next point. All right, so we made it to point number 2 here, and I am gonna go in order for this, but like I said, you don't have to. You can do any order that works for you, whatever's easiest to get around the site. Let's go ahead and get this guy leveled up. All right, that's leveled up. And this is point number 2. So I'll enter that, hit the enter button, and you'll see it automatically makes it to GNSS. So I'll double check my height, everything looks good, and we'll go ahead and measure. See you guys back in 3 minutes. All right, we're counting down inside 10 seconds, getting ready to store point number 2. When that store button pops up at the bottom right, we'll go ahead and hit enter, store it. Okay, so now we have 2 points in here, and we can see some vertical residual now. No horizontal, we'll need 3 points for that, but we can see that we've got about 200ths high on one point and 200ths low on another point. So we got about 400ths worth of vertical error, and remember, we're best fitting that, right? We're using a constant adjustment, so it's splitting the difference there. I'll go ahead and apply point number 2, and we'll head on over to point number 3. All right, so we made it over here to point number 3. I'll go ahead and put the 3 in, hit enter, and it's kind of like wash, rinse, repeat, right? Once you do it once, you just keep doing the same thing over and over again as you measure these points. Enter in the grid point name or the point of the actual, on the ground. And before I measure it, I'll plumb it up. Just realized I hadn't plumbed it up yet. But we put in the grid point name, it'll automatically call it 3 GNSS. Just make sure the code's what you want, the antenna height's right, and of course, plumb it up. All right, it's all plumbed up. I'll go ahead and hit enter and measure. See you back in 3 minutes. All right, so we're inside 10 seconds again, getting ready to store point number 3, and we'll see how our residuals look. There's the store button, takes us to the site calibration screen. You can see things are looking pretty tight. We got 9 thousandths, 16 thousandths, 9 thousandths, 200ths, 200ths, and 4 thousandths. So our control's looking pretty good there. I'll go ahead and apply this 3rd point. And we will head on over and shoot point number 4. All right, we made it over here to our last control point, point number 4. So we'll set up on this mag nail. Plumb this guy up. And you know the routine by now, right? Put in the grid point name, hit measure. So this is point number 4. Type that in, hit enter automatically for GNSS. I'm leaving the code on CP. We've been using it all along for control point. And then 6.562, bottom of antenna mount. We'll hit enter, measure, and I'll see you guys back in another 3 minutes. All right, we're wrapping up our 4th and final control point here, and then we'll check out the residuals once we hit the store button. We're done, so I'll hit enter to store it. And we'll look at our horizontal residuals anywhere from 6 thousandths to 17 thousandths. Again, you want to be within the specifications of the instrument, right? This thing is about 8 millimeters to a centimeter. I'm using an R980. I think it specs at 8 millimeter plus 1 part per million, and we're pretty close to the base station. So, you know, 2 to 3 hundredths, right? I should be hitting 2 to 3 hundredths, and about 1.5 centimeters vertically. So that could be 4 to 5 hundredths, but really you want that probably 3 to 4 hundredths. That is if you have good control. Okay, a site calibration is not going to fix bad control. It's just going to best fit bad control. So you still need good control, garbage in, garbage out, okay? And this control is pretty decent. On the vertical, we've got about a 400 spread like we saw earlier. You know, negative 200s on one, positive 200 on the other, and the other couple fall in the middle, kind of right along the center line there. So looks pretty good there. So I'll apply this last point. I'm going to go ahead and hit escape here. Maybe hit the escape button, get out of the measurement screen. There we go. And what we'll do is we'll go stake out point number 5. So I'll go to measure, stake out, points, and tell it I want to go to point number 5, enter, stake out, and it's that way about 227 feet. I'll see you guys there. All right, made it over here to point number 5, and I turned the IMU back on so you don't have to plumb it up perfectly to stake it out, but I will just prop it up real quick and we'll check out how we're doing. All right, so we're about 2 hundredths in the north, less than 100th in the east, and a cut. It's going from anywhere from 2 to 4 to 5 hundredths, right? It's kind of bouncing around a little bit with the way the satellites are, but you know, we're within a few hundredths anyway. A couple hundredths in the north, almost flat on the east-west, and the cut fill is kind of settling in around 2 to 3 hundredths now. So I'd say that our calibration has been successful. Again, if you have an extra control point, it's good to leave it out of the calibration. That way, once you've calibrated your other control points, you have an independent point to come back to and check into to make sure you did everything correctly. So I'm going to escape out of my stakeout screen, escape again, and we'll head back in the office and we'll take a look at the results here and explain to you guys a few things that are going on in the site calibration. See you back in the office. We're back in the office, and I just wanted to open up Trimble Access and take a look at the site calibration and just cover a few things that you want to check. I know we checked into point number 5 and it checked good, so that gives us a good indication that our site calibration was good, and we looked at the residuals, but I just wanted to show you guys a few of the results that you can look at to make sure that everything looks good in your site cal. So if I go back up to the menu, go to measure, I'll just choose RTK, and there's site calibration in the list. I'll tap site calibration, and here's what we looked at out in the field, right? We've got our horizontal and vertical residuals, but down at the bottom, we have a results button. So if I tap results, here we can see our scale factor and our rotation. Remember, because we did not set those to 1 since we're matching ground control. I wanted it to rotate a little bit. I wanted it to scale a little bit, but what I want to make sure of is that it's not over-rotated or over-scaled, right? So if I look at this, my scale factor has 4 zeros in it. It's a little bit above 1, but it's got 4 zeros. I always tell guys to look at least 4 zeros if they're over 1, and at least 4 nines if they're under 1, okay? You don't want it scaling very much. If you start seeing a lot of scaling going on, it means you have a control issue there, okay? The other thing is our rotation, very small. This wasn't a very big site, probably about 400 or 500 feet across, and we've got about 5 minutes, 5.5 minutes of rotation there. You know, depending on how your site's set up, if they were assumed coordinates, with assumed directions on them, you may see a large rotation, right? So just understand that if your site is on a real coordinate system, you shouldn't have a ton of rotation. These coordinates came from state plane, but they were scaled to ground, and we're going to do construction stakeout on them, right? So we wanted to calibrate to it. So there's a small amount of rotation in there. And then I've got a small maximum horizontal residual there at the top, right? My vertical, you'll notice the constant adjustment is almost half a foot. We got 4,700s, but that's because we did a here position at the base. So we did an autonomous position to start the base. So it did have to move that elevation a little bit. Again, depending on how your base was set up, things like that, you may see more vertical adjustment than not, but that's why I'm seeing almost half a foot here, because I started the base on an autonomous position. But my max vertical residual is only 2/100ths of a foot, a little over 2.5 of a foot, so very small. So statistically, this looks good, but this is something that you need to check. Make sure you don't have too much scale. Make sure your rotation makes sense for your site, and your constant adjustment and your residuals look good there. So I'll just go ahead and hit apply. I'm fine with that site cal. Then one other thing I wanted to show you is if I go back up here and look at my job and look at my job properties now, you'll see where it used to say no projection, no datum. Now it says it is a local site and that these are ground coordinates, okay? Now, another thing that you can do is you can actually save this as a template, and that way, if you want to set up jobs later on for this project using your site calibration, you can do that as well. So what I can do is go up to the top, go to settings, choose templates, and tell it I want to import a template and I want to do it from my SiteCal job. So I'll choose SiteCal, say accept, and then I can give it a name and say this is the Site 1 calibration, you know, whatever you wanted to name it, right? If you had a job name or something like that, you could name it like that. Just name it something that you know what it is. Accept that. And now if I set up a new job and I choose that template, my site calibration is going to be part of it, okay? Make sure you don't use that on any other jobs. That's just for this job. But if you needed to create a new job, or if you wanted to share that with other crews, you can do that as well. All right, so that kind of wraps up our tutorial on how to do a site calibration. I know this was a little bit longer video, so if you made it to the end, I really appreciate it. I hope you got a lot out of it. Remember, if you like this content, please hit that like button. Be sure to subscribe so you get notified anytime we release something new, and we'll see you on the next one.